Our next topic is find the stationary points of a curve and calculate whether they are minimum or maximum stationary points. So first of all, we have to define that what is maximum point, what is minimum point. A point where the gradient of f of x stops increasing and starts decreasing, it is called the maximum point. For example, this is your maximum point of the curve because at that point your gradient stops increasing and starts decreasing, right? Again, a point whether the gradient of where the gradient of f of x stops decreasing. Here the gradient is decreasing and at that point it stops. After that point the gradient starts increasing. It means that this is the minimum point of the curve, right? These are known as turning points and occurs where the derivative of f of x will equals to 0. So how these points can be found? When the derivative of a function is equals to 0, then we obtain some points. These points are minimum or maximum points. Do you have any problem?
No.
Okay. To find the coordinates of these points, you need to differentiate f of x to find the gradient function. First of all, this is the method to uh, find these points. First of all, we have to differentiate f of x to find gradient function. Secondly, solve this gradient function by equating it equals to 0 as as this represents the gradient being 0. Substitute the values of x into the original equation of to find the corresponding y coordinates. So we have to find this because when we put this function equals to 0, then we get the value of x. We put the values of x into the original parent equation to find the coordinates of y. So this is the process of finding these points, maximum or minimum. You can also find out whether stationary points are maximum or minimum. So maximum or minimum points are collectively called the stationary points. Okay, by finding the values of now the other method is that we can find the maximum or minimum points by finding the value of f double prime of x or d square y by dx square. It means that we can find the stationary points by taking the double derivative of the given function. Okay, so at a stationary point, this is because f double prime measures the change in gradient. You obtain f double prime by differentiating f of x twice. So here you can see that if the derivative is equals to 0 and the double derivative of the same function is less than 0, the point is maximum point, right? This is the main conclusion. If the derivative is equals to 0 and the double derivative is greater than 0, then the point is minimum. So it means that the double derivative is less, then it has the maximum point. If double derivative is greater than 0, then we have the minimum point. So we'll discuss in example. Find the coordinates of the turning point on the curve y is equals to x raised to the power 4 minus 32x and state whether it is a maximum or minimum. So first of all, we can write y is equals to x square minus 32x. Secondly, we have to find the derivative, and the derivative is dy by dx, that is 4x cube minus 32. We equate it, derivative is equals to 0 for this condition. After that, we have the value of x, that is 2, right? Because this 4 goes on the right side and divided by 32, it will becomes 8, and the cube root of 8 is 2, right? So x is equals to 2. After that, we have the parent equation, that is y is equals to x raised to the power 4 minus 32x. So we put the value of x into this parent equation according to the previous method that is given in these uh, dots. So you can see that y is equals to 2 raised to the power 4 minus 32 times 2. That will be equals to y is equals minus 48. Now we have the point that x coordinate is 2 and the y coordinate is minus 48. Okay, after finding this point, the stationary point is this point. Now again the derivative is given that 4x cube minus 32, and the double derivative will be equals 12x square and its derivative will be 0. So 12x square is given. Again we put the value of x into the double derivative and its answer will be plus 48. Now double derivative is greater than 0, right? So it means that when the double derivative is greater than 0, the point is minimum point. So you can see that the stationary point is a minimum. Positive number is equals to minimum point and negative number is equals to maximum point. Do you have any problem?
No.
Okay, so this is your example 17. Again we have the example 18 like that. Find the stationary point on the curve f of x is equals to 2x cube minus 15x square plus 24x plus 6. So this is your function given, and state whether they are minimum point or maximum points. So the function is given as f of x is equals to 2x cube minus 15x square plus 24x plus 6, and f prime of x is equals to 6x square, because the derivative of 2x cube is 6x square and 15x square is 30x and 24x is 24. So this is a quadratic equation. We equate, we just put this equation equals to 0, and you can see that here 6 can be taken as common. So your answer will be 6 times x square minus 4 and x minus 1 is equals to 0, because this is a quadratic equation and we solve it using the factorizing method. Understand? So the factors are these. So first factor is 1 and the second factor is I think there is a mistake. This will equals to plus minus 2, right? Because this is x square and x square minus 4 is equals to 0 can be written as x is equals to plus minus 2. Okay, so there is a mistake. Okay, so substituting into the original formula will give these coordinates as stationary points. First of all, when we put x is equals to 1 into this function, you get your answer, that is 17. But there is not a mistake, there is a simple uh, misprinting, that is not x square, that is simple x. Now this is clear, right? Do you understand?
Yes.
So this x square is not here, this is simple x. So we have two values of x, that is 1 and 4. When we put 1 into this parent function, we get 17. When we put 4 into this parent function, we get minus 10. So these are the 2 points. Now we check that which is maximum and which is minimum. So for this purpose, we take the double derivative. So it will becomes 12x minus 30 plus 0, and 0 can be neglected. Again, when we put 1 into this double derivative, you get your answer, that is minus 18, right? And when you put again 4 into this double derivative, you get positive 18, and this negative sign indicates that this is the maximum point. It means that this 1 has the point, that is 117. It means that 117 is a maximum point, and it is positive, and positive can be generated by this point. So it will becomes 4 minus 10 is the minimum point. So do you have any problem in this example?
No.
Okay, so you have to do till this example. In the next class we will start from this example. Okay, so that's enough for today. Okay, Allah Hafiz.
Allah Hafiz.